Hey, Math 30-1s, how's it going? Welcome to part 4 of this lesson. This is day 2, I guess, part 2 of day 2. So today we're going to talk about coterminal angles. We already talked about them. Just remember that a coterminal angle is an angle which lands on the same terminal arm as another angle, right? So it has to land in the exact same place. So it says right even here, arrive back at the same terminal arm, right? Now, again, there's an infinite number of these. The previous example, I only drew one time around the circle, but I can keep on going around the circle as many times as I want. As long as I stop on that terminal arm, that's my angle. I just keep on adding 360 each time around the circle. So you can see here, what I can create is what we call general terms when we do that. So this right here and this right here, these are what we call general terms, where you're kind of doing kind of strange little math here. You notice one's in degrees and one's in radians. That's fine, because 360 is the same as 2 pi. But what they're doing here, imagine I have a circle, not a circle, a terminal arm. Let's put a terminal arm right in this quadrant again, quadrant 2. There's my terminal arm. I'm going to draw my standard position angle. This is my principal one because this is my smallest one. Doesn't really matter what this is. Let's just say that this is 125. Okay. Now, a coterminal angle would be this angle up to here plus a whole nother circle from here to here. So I'm adding, so this piece here would be 125, the original 125, plus a whole circle afterwards. So I'm adding a circle. What I could do now is if I want to come back to the same spot, so I could do the same thing. It's kind of hard to do that. I'm going to go around, I'm going to come to the end, and then I'm going to draw this and keep on going again for another circle. So that purple one I just drew there is the pink one with a little bit more to it, but you notice that it adds on again. So the purple one would be plus another 360. And I could do another one where at the end of that purple one, I go again and go around. Oh, that would just be another 360. All these are coterminal to each other. They start off with the 125, add 360, add 360 more, add 360 more. So you have a bunch of different answers. 125 plus 360, 485. So that would be the pink one there. Pink one's 485. Another one after that. So just add 360 to this one. So the purple one would be 845, and then I'm going to add another 360 to that, and I get 1,205. So all of these are coterminal to each other because all I did was just add 360. Now I could, nothing stopped me from doing this. I can go here. So let's draw that same one here, but what I could also do is I could do this. Let's pick this one here. I can start here and go this way. There's a coterminal angle. Now what this coterminal angle technically is, if you did this, I went 125, and then I went back around the other direction and came back here. So I subtracted 360 from the 125 to start off with. And then I keep on going back around. I keep on subtracting more 360s from that. 360 minus, 125 minus 360 gives me a negative coterminal angle of 235. And then I keep on subtracting 360 from that. I keep on going even deeper if I wanted to. Negative 595, et cetera, et cetera, et cetera. Okay. So I'm adding 360 or minusing 360. Now what these little equations up here are saying is you're adding 360 like we were doing, right, times n, where n is an integer, right? And remember what an integer is, it's just a positive number, it's a negative number. So I can either times it with a no decimal, sorry. So I can either times by 1, which is 1 time around the circle. I can times it by 2, which is 2 times around the circle. I can times it by 3. Or I can times it by -4, which is 4 times around the backwards, right? So I'm subtracting 4 360s, right? If everything is in radians, you just say 2 pi because 2 pi is the same as 360. And again, I'm just going to be multiplying it with NEI again. Sometimes they might see an NEW, so as a whole number, but you only see these kind of things with integers or whole numbers because they don't have decimals in them. Okay. So what we're going to do for each of these is just determine some coterminal angles. So I'm going to give you time. If you want to pause, you want to try this out, you can. Okay. So hopefully you tried that. Oh, geez. Hopefully you tried that out. So we have 360. So maybe, or not 360, I have 36. Maybe I'm going to draw these out first just to practice drawing standard precision angles. So let me just get my black marker back out here. So there's 36. It lands in the first quadrant. Its reference angle is also 36 too, which is kind of convenient. Okay. Now a coterminal angle would be this 36 plus another 360. So I could just add 360 to it. Okay. So it says determine one positive coterminal angle. So it'd be 36 plus 360. So this one here would be 396 degrees. And then I could also then just take this, go from this point. So I can go up to this one and then back up 360, go back the other way. So 36 minus 360 would get me, so this one here would be minus 360 degrees, which would end up being negative 324. So there's my two coterminal angles. Those are just the next ones. I could just add or minus 360 to these all I want. Got huge numbers. You could just say, okay, in your calculator here, I got my number. If I got my number, I just hit minus 360. It says answer minus 360. Just hit enter about 1,000 different times. I get a bunch of different numbers there. All those are coterminal because they're all 360 from each other. But just try to make it nice and easy and always pick the ones that are the next ones. Now, both of these are positive. The 36 and the 396 are both positive, but only the 36 is the principal angle. Right? Let's just go ABC for these ones first, and then we'll come down to these general expressions later. So negative 145 lands in this quadrant somewhere. So this angle here, not quite negative 180, like this would be negative 180 over here. This is negative 90 down here. So that's where that would be. And this would be one of my coterminal angles, which would be the same as going from here and then backing it up all the way to here. So you're going to go to negative 145. I'm going to add 360. If I add 360, I get 215 degrees. Or I can just keep on going backwards, keep on subtracting more. So I can go to negative 145 and then keep on going. So I could subtract 360, keep on going even more negative, and get negative 505 degrees. All right. I'm just going to draw this one out, but I'm not going to draw all the little circles, but 210 would land somewhere in this quadrant. It's past 180 and a little bit more. So that's 210. If you want the reference angle, remember, find those out. So 210 minus 180. So I can go 30 degrees here. That's the reference angle. That's not really important. Like here, I can find the reference angles for this one too. Just be 35 degrees on this one. You see that we're not using the reference angles here, but I just like the practice of finding reference angles. But the two coterminal angles would either be plus or minus 360. So one of them would be 570. And the other would be negative 105. So there's my two coterminal angles. Now, the general expression, that's what these are called. They're called general expressions. I'm just going to put that here. General expressions. These are going to show up later on too. But it's good to start practicing them. The general expression for any angle that's coterminal to these would be an angle. It doesn't matter what angle. Usually when you write these out, you always write the principal angle down. But it could just be whatever angle you want, whatever angle you start off with here. Maybe because you start off with the negative 145, we can write that there. In this case, we got 36. That is my principal angle. Plus 360 n, where n is an integer. Right, so that just means I'm either times by 1 or times by negative 1 or times by 2 or negative 2. But no half times around the circle because these are always going to be full times around the circle. So this one here, I usually want to use my principal angle. So the smallest positive angle here is 215. Now, there's nothing wrong with using the other angle. So I could write this by using the negative 145 they gave us. That's still right. It's just not in convention, mathematical convention, that mathematicians have decided that let's just use the smallest positive one to put first. It's like here, 210 is the smallest positive number. And then I'm going to add 360 degrees N, N, E, I. Okay, there we go. Okay, so when we're doing this with radians, finding coterminal angles, it's sometimes nice to change these into degrees to find out exactly where they are. I'm not going to write the degrees down because we're given radians. So I'm just going to change this into degrees. Just 1 second. All right, so if I switch this quickly into degrees, this is 60 degrees. Remember, you could just switch the pi to 180, 180 divided by 3, 60 degrees. That just allows me to draw this nicer. So I can say that this is 60 degrees. This is pi over 3. So I'm not going to write 60 degrees down here. And my coterminal angles are going to have to be left in radians. So rather than just adding 360 to 60 and then changing it to radians, remember what we did before, one of the previous ones there, when you want to add 2 pi to something, and the other thing also has pi in it, you would just add the numbers that would be in front of them. So like here, I want to add 2 pi to 1/3 pi. I'd look at this, oh, they both have pi in common. So I would just factor that out and then just add the 2 numbers that are in front. So 2 plus 1/3, math, enter, enter. This will be 7/3, and then if I just multiply the pi back in, 7 pi over 3. So you're really just adding the numbers in front. So the first coterminal angle, which would be plus 2 pi, which is the same as adding 360, is 7 pi over 3. Then you can do the same thing. So you go 1/3 minus 2. And remember, these are both pi's. Math, enter, enter. So if I minus, oh, stupid thing here. Hit the button on my stylus here. Minus 2 pi. So I'm minusing just the numbers in front. I get negative 5 over 3 pi. Okay, so those are my 2 coterminal angles. Now, if the angle's given to you in radians, answer in radians. If they're given to you in degrees, answer in degrees. Okay, so an expression for this would be pi over 3 plus 2 pi n e i. So you're adding 2 pi to each one of those or subtracting 2 pi depending on what value of n you have. So you're going to do the same thing with this. I'm just going to draw them out first. So negative 5 times 180 divided by 6. That is negative 150. So that's in this quadrant down here. It's not quite negative pi yet. So it's somewhere in there. And to find the coterminal angles, you either add a pi or subtract a pi. So plus or minus 2 pi here. I'm going to just ignore the pi's because they both have a pi in them. So negative 5 over 6 plus 2 will get me 7 pi over 6. And if I go negative 5 over 6 minus 2, I get negative 17 over 6. I put that pi back in there. And there's my two coterminal angles. One positive, one negative. My expression would look very similar to the other one. I want to use the first positive one based on convention. So let's just do that. So I'm going to use the 7 pi over 6 for that solution. 7 pi over 4 is the first positive. You can do the math on that one, try to figure that out. But it ends up being the first one. And there we go. And that ends up in this quadrant down here somewhere, in the fourth quadrant. Let me just quickly figure out what it is. So it's like, oh no, where does that end up? It ends up being, well, it's not the smallest one. My bad, sorry. I had to figure out what the smallest one. Actually, if I did the math, oh, is it? Just a second. It is. It's the smallest one. What am I thinking? It's 315. I put 360 by accident in my calculator. But it's 315. So I'm just going to leave this here. It is my smallest positive angle. 315 lands in this quadrant. There's my standard position angle. All these are going to be drawn in standard position. Like I said before, if they don't mention it, always draw it in standard position. Then I'm going to add or subtract 2 pi from that. 7 over 4 plus 2 is 15 pi over 4, and then 7 over 4 minus 2 is negative pi over 4. So negative 1 over 4. So I just put the pi in there, so I don't have to write the 1. There you go. So that's how you get coterminal angles. Again, if you just kept on going, you could just keep on adding or subtracting 2 to those numbers. Now, a side note would be, which question is this? A, B, C, D. There's a bunch of A, B, C's, D's in here. Let's call this G or something like that. If my angle was in a decimal form for radians, say I gave you like 2.6 rads, the coterminal angle for this would be this number plus or minus 2 pi. But now, because the other number doesn't have a pi in it, you would have to include that in there. So I would have 8.9, depends on how many sig digs they have here. So I would add the 2 pi with the pi in it. So 2 times pi is like 6, 6.28-ish. So I'm going to add that on there. Or I can subtract it as well, 2.6 minus 2 pi. Remember, always use the pi button. Don't just approximate it to 1 point or 3.14 or just 3 or whatever. Always use the pi button. Cool. That's just that little side note put in there. That ends off this lesson. The next lesson we are going to talk about the unit circle. Why 360 is such a nice number. Why do we want to use the unit circle? Actually, there's a bunch of reasons you don't want to use it, but mathematicians love the unit circle, so we're going to use the unit circle. And you probably remember these from Math 20-1. These are special triangles that we're going to be using too. Okay, so I'll see you in the next video. Bye.